Hello, welcome along to the latest in our series of webinars. This one is entitled Small Data, Big Wins. A little bit of housekeeping just to get us going. You should all have the GoToWebinar control panel on the right hand side of your screen. If you do have any questions as we go through any of the presentations today, then just type them into the little box at the bottom, and we'll have some time at the end of the sessions to go through a bit of Q&A if there's anything you want to ask us. Anything we don't get to answer, we'll respond with a quick email, or again, if you think of something after the session, then please drop an email along to inquiries@simlogic.co.uk, which is on the bottom of your screen just there. So a brief agenda, we'll give you some brief introduction as to who we are and why we think you should listen to us, a little overview of SimLogic, and then the presentation topics Steve is going to run through trying to avoid drowning in the data lake, and I will be looking at how you turn that into tangible wins and tangible benefits. So as I said briefly, my name is Fraser Thompson. I've been with SimLogic now for about the last 11 years. I'm a controls engineer by background, but I'd say for the last kind of 8, 9, maybe even 10 years, I've been kind of moved into a mainly kind of customer focused sales role, focusing on MES and the areas within MES such as OEE, quality, warehousing, and so on. Manufacturing is my passion. I love to know how things are made, where things are made. I'm the worst person to take around the supermarkets. I'm always picking things up and having a look and seeing where they come from and so on. So I have a lot of experience in kind of food and bev, pharmaceutical, CPG, automotive, that hopefully we can bring to the table. All right, Steve?
Yeah, hi, I'm Steve Wilkinson. I've been with SimLogic for nearly 15 years now. Looking forward to my big present next year.
It's watch time.
Yeah, I started as a control systems engineer back in 2005. And I've had many roles since, solution architect, and recently become CTO, and so I lead up the roadmap for SimLogic in terms of our technologies that we use and products that we use, and really kind of enjoy seeing our customers getting value out of the technology that we can connect them with, and really getting value for all of our client base.
So, just as a brief overview of SimLogic, again, as we mentioned in both our bios, we both kind of started as control systems engineers, and that was kind of really the history of the company going all the way back to kind of 97. We were kind of your run-of-the-mill systems integration company, PLC SCADA systems, and as our kind of customers' needs evolved into, can you just give me some reports or some data for this, then so did our kind of skill set really. And we kind of moved from a pure systems integration company into the MES space and into looking at manufacturing improvement and how we can use our skills to capture data, analyze data, and drive kind of productivity improvements within our customers' sites. That's really kind of what we all kind of pride ourselves on. The bulk of the people here are kind of engineers by trade, and we love kind of solving problems. We're based up in West Yorkshire, lovely part of the world. That's our building there on the bottom of the screen. We're in Salts Mill, which is obviously one of the kind of birthplaces of the original industrial revolution, if you like. And here we sit at the kind of, I don't know whether it's the start or whether we're kind of well into the fourth industrial revolution now. But so the buzzword I will try not to use for the rest of the session if possible. Again, we work with a variety of different customers in different sectors, from, again, food and bev to pharmaceuticals and so on. So hopefully there's a lot of experience that certainly we can bring to the table and help us take our learnings from some of our other clients and introduce them to your business and your manufacturing processes. So without further ado, I'll hand you over to Steve, who's going to run through the first part of the presentations on don't drown in the data lake.
Thanks, Fraser. Yeah, so I guess we hear a lot of talk about data these days, and expressions like data is the new oil and things like that. And interesting kind of statistic when I was researching this is that's predicted by next year there'll be 44 zettabytes of data that we've generated in our digital universe in the whole of the world. I didn't have a clue what a zettabyte was, so I went and looked it up, and it's a billion gigabytes, I believe. No, a billion terabytes.
A billion terabytes.
Yeah, which yes, and a terabyte is 1,000 gigabytes. So and that one we're a bit more familiar with. So we're talking about you know, an incredible amount of data that we can't even begin to kind of interpret and imagine. And it's reckoned only about 37% of that would actually be useful. But, you know, 37% of a zettabyte is a lot. And so it really sets the scene for that incredible amount of data that's already available and going to be available. And really we want to talk today a little bit about how we can actually start to make sense or use of any of that. Where we always start at SimLogic is with the knowledge pyramid, or the DIKW pyramid. So down the bottom you have the data layer, so all this data that's being generated. And what we want to do with that is try and get some kind of information from it. So we have to contextualize it to actually turn it into information. And then when you have some information that you can look at, we can gain some kind of knowledge. And only then, really, have we got anything valuable from the data, because that's the point we can turn it into wisdom and we can make a decision based on what we know now that we didn't know before. We can make an informed decision, and that's the kind of wisdom piece. Now, what we typically see in manufacturing or day-to-day is that there isn't always a connection between the data layer and the wisdom layer at the top. So you have a scenario more like this, where your wisdom and data aren't aligned. And how this kind of manifests itself in the real world is decisions being made by gut and by experience. And so a common one we might see is when we go into a manufacturing site, shift A always run the line at 100 units per minute, and then the night shift come up and turn it up to 110. So the day shift believe it has less stops if it runs slower. The night shift believe they get more out if they run it faster. And then if you look at the machine manufacturer's spec for that machine, it might say 120. And somewhere along the line, these decisions are being made without real data driven wisdom to actually know who's correct.
Well, there's not often a lot of data in that picture at all. It is just that kind of gut feel.
Yeah,
that's used more often than not, isn't it?
Exactly. Yeah. So they, you know, typically they'll be wanting to make the production by the end of the shift, and one team will believe it happens quicker if we do it this way, and the other one will believe it happens quicker this way. And it's rarely based on actually any kind of facts. So the goal then really is to try and realign these 2 points on our pyramid, so that we're actually making decisions based on what the data is telling us. And that's really been the case for many years, certainly as long as I've been doing this, for nearly 15 years, but before that as well, you know, since we started connecting PLCs to networks, that really has been the driver, is to get that data out of these systems, move it up this kind of value chain and start making decisions based on it. And on the screen here, there's a kind of traditional approach to that has always been, you know, have your shop floor devices. They may be controlled by PLCs and other controllers. Above that, you might have a SCADA layer for controlling and doing some data acquisition. And above that, some kind of reporting layer that might tell you how effective or efficient you're being, help you make decisions. And finally, above that, kind of ERP layer where we're doing planning and all these sorts of things. Yeah, exactly. Yep. And as you move up that model, the kind of time frames that you're working in get longer and longer, and the time it takes to collate the data traditionally gets kind of slower and slower. So in SCADAs, you might be dealing with what's going on right now and what's happened in the last hour or during the last batch, that kind of thing. In your operations management layer, you know, you might be looking at how we ran last week, and by the time you've actually collated that information. And ERP layers, you might be looking at weeks to months to, you know, forecasting next year, that kind of thing. So the data kind of speed, if you like, gets slower as you move up these in the kind of traditional model. And so I say we've been doing that for years, and I guess if you don't believe me, there's a picture of me almost those 14 years ago in front of this very picture in our office, looking a little bit different, although my hair's only slightly longer than it is today. And so, yeah, that's really shaped things and shaped our kind of company for a long time. And what we're seeing now with the kind of new technologies that are emerging, industrial Internet of Things, is that although these drivers haven't changed for getting data and making better decisions, the way that you can do it now has been greatly improved and sped up. So if we look at the traditional approach for filling in these layers, it's very much been a kind of bottom down approach. So you know, I've heard several large companies say this still recently, that the first thing that they're going to do on their digital journey is to connect everything they can across all of their factories to the network, to a big server, have a central historian, single point of truth, put everything in there, and then we might be able to do something with it. And it's kind of, well, what are you going to do with it? Well, we're not sure yet, but we've got all that data. Won't it be great? And while that's great, if you are extremely wealthy, most people want to see a return for what they're doing early on, rather than making that big leap. Your pyramid filled up very quickly there. That's not the that's not the case normally. People can spend many years just getting a percentage of the way through the data layer, taking that approach. Yeah, and people have been, and that's why when you kind of talk about Industry 4, a lot of people say things like, oh well, we're not even Industry 3 yet, and that's because they're looking at this kind of bottom-up approach of well, once we get all our data and we have an information layer, and then we can create some knowledge, we might hit Industry 3, but what we're seeing with Industry 4, these technologies actually allow you to almost take a slice of that in a different way than we would before. So we'll have a little look at that. And interestingly, even these companies that have got access to a lot of this data, only 1% of it is actually being analyzed. So, if you think about that in terms of opportunity and why bother actually logging all of that data, is we're only going to be able to make use of 1% of it anyway, or have the time to make use of 1% of it. It really does question why you would do that approach. 99% wasted effort almost. And I mean, I guess some of these bigger companies that we talk about, reckon they might be at near 5% here. I don't know how they'd estimate that, but even then you're kind of doing 95% waste. So what we're really aiming to do is find a way to not worry about all that data. So if we look at what the pyramid is probably like, it's very skewed in terms of the amount of data that's available. How do we pick the right stuff? We've already discussed how it's not really realistic to log all of that. So we have this more skewed kind of knowledge pyramid, and actually these areas of unused data is kind of termed dark data. So this 95% or 99% that we talk about is dark data. And I guess where we want to be is in a position where we're not spending huge amounts of money to pull dark data that we're never going to use or isn't going to be any use to us. So it's all about picking the right thing. And I love this picture of a cake. So, features a lot in my presentations, but this comes from my kind of background in agile software development. But in agile, one of the key principles is to always work with an MVP, so a minimum viable product. So this is something that it's the smallest thing you could build that will deliver you some value or deliver the end user some value. And the analogy that's typically used is of a cake. So if you want to eat some cake, you want a slice of the cake. You don't necessarily want to, you don't want to eat one layer at a time. It doesn't make the cake as exciting. So the objective with Agile and this kind of thing is to think about how can we build a single slice of cake that delivers everything we need, each layer from the bottom to the top, and gets us that value. Leaves you nicely satisfied. Yeah, with the cherry on top and everything. So rather than building all those layers up, it's the same analogy with your pyramid. Why build all the layers if you can get a nice slice of that? Okay, so we're looking for the exact same thing on our knowledge pyramid. Is how do we get a little slice that ignores the dark data, but takes us from the bottom to the top, gives us some wisdom and lets us reinvest. So rather than doing everything, let's find something that brings some value, so we can prove it, make some decent decisions with data, and then prove that we have some value returned and use that to reinvest in somewhere else. And slowly you can start building up other parts of your cake. So I guess some pointers on what we think to do this, how you could best go about this, is to start with a Lighthouse Project. So the Lighthouse Project is another term for maybe like a pilot or something like that, but with the objective of showing the way for future projects, to say, well, we want to embrace digital or IoT or whatever it may be. Let's start with something that can show some value, demonstrate how maybe we can do it in future, and don't try and do everything at once. Always have a question to answer. So don't embark on a project purely for a technology sense. Make sure there's a reason that you're going to do this and that there's some value to get out of it, and understand what that value is up front and why you want it and why it'll be valuable to you before you even start thinking about the technology to use, the data to log, this kind of thing.
Just because it can be done doesn't mean you should.
Exactly.
You should do it.
Yeah. And point 3, I would say, is work backwards to the data. So start at that point of, if we knew the answer to this question, it would be this much value to us now. Now we know the question, what do I need to go and get in order to find the answer out? And so don't limit yourself by choosing the technology first and thinking, oh, great, I've found a really nice IoT sensor, let's put that on my machine and see what it tells me. Think about what you want to know and work back to the data. And if you don't know how to get the data, speak to someone like ourselves who can help you there. Because often we're finding that with new technologies, getting this data is much more affordable than it used to be. And that really paints a different picture now of our traditional landscape, where things can go instantaneously from the shop floor to the people who are making decisions, and that might be through mobile devices or web-enabled browsers, that kind of thing. So it really shortcuts that traditional approach. So not just in terms of infrastructure and how we get the data there, but those timeframes as well that we're working in. But actually now, there's no reason in your ERP layer that you can't be making decisions based on real-time information from your shop floor. And so just a quick touch on the technologies there, but I suppose the things that are enabling this to happen are things like the IIoT, so many I's in there, Industrial Internet of Things, microservices. So they're kind of less talked about, I suppose, but every IoT device you have needs to speak to something. And so microservices are like really small bits of software that do typically one job. They do it very well, they're very scalable, very efficient, and not complex at all. So normally don't typically go wrong. And then cloud computing. So our IT manager always says there's no such thing as a cloud, it's just someone else's PC, which is true, but you haven't had to pay for it, and you're just borrowing a small chunk of that really super powerful computer. You're paying for what you use. And so for doing things like Lighthouse projects and pilots, it's a really great enabler to start small, scale it if it works. If it doesn't, turn it off.
Time to value.
Yeah, of course. And you've not lost anything if it doesn't work. You haven't invested in massive server hardware and that kind of thing. And finally, mobile. So getting that information back out to users. All of us have got a mobile phone in our pockets, not always on the shop floor, but we're seeing more and more mobile technology being used. Tablets and so on the shop floor. So get that information back out to people as quickly as we can. And so they're really the enablers that I think allow us to kind of get that slice. And so don't go put IIoT everywhere, but think backwards about the problem you want to solve and use a similar infrastructure to try and get that information. And then hopefully you can kind of...
There's that cake again.
Well, this is where I've been building up to the big pun, because you can have your cake and eat it. And
there we go.
There you go. So you can literally find that slice and hopefully get some value from it, and maybe even put a cherry on top.
Lovely. Right. Well, thank you, Steve. I'm going to kind of pick up a little bit where kind of Steve left off now. So we're going to get hold of some data, but how are we going to kind of use that data to drive some kind of improvement, to get some return, whether it be a cost saving or an increase in sales or whatever it might be. And there's a lot of certainly a lot of talk in the industry at the minute about Industry 4, IIoT. IoT, I think, is probably the best description of it, because it takes the kind of technology that you're used to using at home, the IoT, and makes it industrial. Think about what you would be able to use at home and use the same kind of things, the same kind of approaches in an industrial environment.
Yeah, I guess the difference is at home it's getting ridiculous, isn't it? It's like smart everything, smart
Yes.
toasters, smart whatever.
Yeah.
There's not actually any use for, but if you think about that in manufacturing, there's so many uses where
Yeah. What are the problems?
if there was something smart, and
Yeah,
you could really benefit.
Absolutely. The problem is that the use cases in manufacturing are very much on the extreme side of things. You know, I'll go and do the kind of networking and presentation circuits in our space, and it's always, you know, the kind of same talks about digital twins, and, you know, well, how maybe Rolls-Royce had a digital twin of all the jet engines, and they captured 100 million data points per jet engine, and they used it to simulate whatever. And straight away, going back to Steve's kind of 1%, 99% of your audience there is going to turn off, because they'll think, well, I haven't got that kind of budget, and, you know, if I don't have the same level of safety concerns as if something goes wrong with my jet engines, is the level of investment, which is also extremely high, worth the carrots, if you like, at the end of the stick? And the answer for a lot of people is they can't put two and two together yet. And it's very much similar to how you would kind of see the kind of future of the truly automated car, the self-driving car, if you like. We're slowly being drip-fed in our cars at the moment, little bits of technology that enable little bits of functionality to start to be used and start to be trusted by people, because it's people that have to trust it. You know, if my car's got like a lane keep assist on it, it will hold itself in the lane on the motorway that I want to, and will kind of instruct me or guide me to if I'm starting to drift, for example. But it's a small piece.
Yeah.
It enables me as the user to start to trust the technology, rather than just saying, I remember yesterday you were completely driving this car manually, and tomorrow you're just going to sit in the back and not touch it. It's going to do it itself. Everyone's going to go, that's not for me. That's not for me. And it scares people off. So the approach the automotive industry is taking is to take those small chunks and deliver them all the way through. They haven't gone for the full self-driving autonomous car yet, just to do the kind of small chunk. And that's the kind of approach that we need to take in manufacturing. And it's, you know, in continuous improvement, you'll be thinking about, how do I go out and get the low-hanging fruit? And for me, things like digital twins sits firmly at the top of the tree. You know, it's right up there. I'm going to have to get cherry pickers, ladders, increased risk of health and safety to go and pick that fruit. It might be the juiciest, ripest fruit in the world, but there's certainly plenty at the bottom that we could be going for if we knew how to do it. So if you look around, you'll find this term small data, and going back to Steve's pyramid idea, that little chunk of the data layer at the bottom that's not bad data, it could be small data. And the idea of small data is it's data that's small enough for humans to comprehend it, really. How can a person make sense of what this information is telling, so they can take it all the way through that pyramid to the point at which you go, oh, I've got my insight now. I know how to change what I need to change to make an improvement. So as humans, again, we need to be able to trust what machines and what data is telling us in order for us to start to buy into it. And there's a lot to be said for getting people to kind of buy into technology and data solutions as well. So as it says on the screen there, small data will connect people with timely, meaningful insights there. You know, yes, big data is fantastic, and the analysts, the data analysts, data scientists, they want big data there. IBM Watson needs a big data set to throw your machine learning at it. But if you don't trust the output because you haven't been involved in the kind of stepwise process, then has it been useful to you? And the answer very often is no. We need to take people on that journey. And the point of it is that, yeah, big data is about machines, and small data is about people.
Yeah.
And again, 99% of our issues are going to be about people, not because people are bad, but because, you know, people are difficult, they're unpredictable. A machine is quite predictable. We programmed it to do this, and it will do that as long as it is operated in that condition. You know, when my packaging machine doesn't operate correctly, it will normally be because it hasn't had its maintenance routine done by people as set out. It hasn't been set up to the correct conditions by people as they've done a product changeover. The machine itself, you know, should be fundamentally pretty sound. So how do we kind of do about that? What's stopping people making that first step? And it is all about infrastructure and infrastructure costs. As Steve mentioned in his presentation a little bit earlier, to get that data layer in, we're talking about 7-figure sums. We're talking about devices that don't have any connectivity, where you've got to enable connectivity. And when you do enable connectivity, you open up a whole can of worms, like cybersecurity, for example. We know, obviously, over the last couple of years, with the various cyber attacks that have happened out there, it's a kind of growing risk for people. It's in the front of mind when they're thinking about these kind of projects to get something going in this space, and that quite often will kill these projects dead. And you won't ever get to the wisdom and the value at the top of the pyramid, because you'll take 5 years, be a quarter way up the data layer, and go, do you know what, I'm not seeing any returns from this. Let's just stop and get back to what we were doing. But as Steve said, it kind of needn't be that way. So we're certainly making use of a lot of technology that's out there at the minute in terms of wireless connectivity. Some examples are on the screen there in terms of wireless sensors that can be fitted in an ad hoc manner to existing sensors that you've got on the shop floor, that will allow communication of their data via secure wireless networks. Again, so I don't need this kind of big infrastructure costs about, oh, it's going to cost me X to pull some cables, run some containment. I can only do it at the weekend, so the labour rate to get an electrician is higher. But that needn't be the case anymore. There are solutions that are out there to kind of shortcut that. We want to fast track, as it says there, your continuous improvement journey. And that should enable you to get data to justify go out and grabbing some of this kind of low-hanging fruit. And if we think about a continuous packaging line, maybe where we're making bottles, or we're filling liquid into bottles as example, some of the things that you can get from some very kind of quick wins using like a single sensor type approach would be line speed or short stops. Perfect example of that would be if somebody is capturing downtime data. Currently they're probably doing it on paper, maybe in Excel. Everything would be in chunks of 5 minutes, because that's how people's kind of brains work. But there'll be no indication of line speed, or if there is, it will be, I'll go and have a look at the HMI and it says 500, therefore I'll write 500. As the kind of line operator's brain, you don't have the ability to visualize that line and make a judgment call as to whether it's running at 450 bottles a minute or 470 bottles a minute. You can't do that with your own eyes in real time. But with a single sensor that's counting bottles and giving you a real-time speed, you can. That single sensor would also give you, for example, the number of short stops. So any of these stops that are less than 5 minutes before they get back up and running again, that don't currently appear on any of our spreadsheets or our data sets, or even looking at the accurate time of changeovers. Yeah. Again, starting with the question, how long are our changeovers? Well, if you, more often than not, if you tell somebody that a changeover should take half an hour, what are we going to write down on the sheets? Funnily enough, it's normally 30 minutes. So how have we been able to do that in the real world, if you like? I've got one example here. I won't name any names in this particular example, but I've got a canning facility that's set to run at 500 cans per minute. Right? We have a single sensor on the in-feed to the machine that was going to count the number of bottles it was actually making, and what we were able to detect was that machine was actually running at 497 cans per minute. Now, a great deal of conversation ensued after we kind of presented this information back to them. There was multiple weeks of kind of back and forth, because the first thing you've got to overcome is that barrier of a person's opinion who is perhaps not engaged with the data or doesn't understand where the data's come from. You've got to get them to believe the data.
Well, that's the gut and the experience part, isn't it?
It is. It is. So, yeah. I mean, the example there was, okay, well, The HMI on the machine clearly says 500. But I can tell you that we're counting bottles as they go into the machine, and it's 497. So where's the truth? And this back and forth ensued, and eventually we got to the point where we thought, right, okay, what I'll do is I have to go get a tacho, and we'll go and measure the physical speed of this machine as it's turning around and see what actual speed it's running at. And lo and behold, it was running slower.
So again, you have to go and get the same data, but without the technology to gain trust in what the technology is telling us.
Use a piece of technology that somebody trusted, a tacho,
Yeah.
To tell them that was what was happening. But we needed this real-time data to kind of expose it, to shine a light on it. Your Lighthouse Project type example. There was a piece of work that happened after that. They had to go and correct whatever it was that was wrong with the machine to make sure that it was running back up at its full speed. But the effect of that, is kind of quite large. We look at 3 cans a minute improvement, and on average they were running around 80 hours a week. That gets you an extra almost 750,000 cans production per year for the same overheads. You haven't had to employ any more staff. You haven't had to keep the lights on any longer to get that improvement, and it's there, and it's real, and it's tangible.
It soon adds up as well, isn't it? You wouldn't typically imagine a difference of 3 units per minute could have such a large effect over
such a big effect.
Without actually seeing some numbers and thinking about it in that sense. Because
you just see that the line is running, and it's running quite fast, therefore that must be good. Therefore there's no problem. Another example, looking at again another bottling facility manually collecting O-level data with a high level of unaccounted losses. So that would be, I'm looking at all my spreadsheets, all my data, and it's telling me that my OEE is this, but I've only produced that. There's something missing in the middle. What's going on? And the answer again, as kind of alluding back to the low-hanging fruit on the tree example, was these short stops. These stops less than 5 minutes that weren't being captured. What we were able to do is identify those, look at actually the duration of time that those stops were, and actually the bulk of those stops, I think around 80% of the stops were less than 20 seconds in time. By analysing that, by looking at the way the balancing on the line was working, by saying actually there's some hidden capacity here in the conveyors on the line. If we make some adjustments to speed some machines up, slow some conveyors down, we can get the bottles to stack up closer to each other. We can absorb that 20 seconds in a clever way by using a control philosophy. And again, that was able to increase their OE on this production line by almost, or just greater than, in fact, just greater than 10%. And again, very little time, very little investment spent to try and capture that information with real tangible benefits. If you look at the kind of things that sit around that, actually, that round about 10% improvement in OEE meant that this particular client didn't have to run overtime shifts, and while they weren't running their overtime shifts, the lights were off and the power was off. And while the lights and the power was off and the overtime shift wasn't in, funnily enough, there was nobody in the canteen as well. So there's also kind of residual benefits, as well as the actual, the first saving being overtime reduction. There's other things around that. You've got to be able to put, again, a tangible kind of pounds and pencil, dollars is in this case, benefits on these improvements. And that would then lead, hopefully, to somebody to go, there's value in this data. Let's go and get some more of it.
Let's do some more,
Let's get some more. Let's do some more. Let's get some more wins. And there's all sorts of things you can do. Product overfill is a big one in the kind of food and beverage industry. And it only takes a very simple solution to connect to a benchtop scale. It doesn't even need to be an in-process check where you get in every single unit. Just by getting a connection using an IIoT device with some microservices. Remember that one. Capture that data, log it, use it to drive some improvements. Again, we're able to drive around a 20 to 35,000 pounds per annum saving on product overfills. And it's really simple, just by every time the operator takes his 5 or 10 samples off the line and weighs them, rather than letting them write it down, or let's not say it, but make it up at the end of the shift because they forgot to do it on time. It's actually capture it in real time and notify them when it hasn't been done in real time. Capture the accurate reading from the scale and not just have somebody know that it should be 75 grams and write down 75 grams. Let's get the truth. and use that truth to drive some kind of improvement.
It's a really easy one to visualize as well, but if you're putting less of your valuable product in a bottle, you're saving money. So it's quite an easy one to.
As long as you don't upset the market, obviously, by making it look less full, which is obviously a big key win. And the last one I mentioned at the bottom of the tree there was kind of changeovers. And again, we've kind of been there. We've worked with the big companies, with the big data scientists, looking at kind of changeover analysis. We thought this was going to be the next best thing. We've taken a big data set. We can predict every single one of your product changeovers using this big data set. Isn't that fantastic? No, it's not, because again, the people didn't trust the data, and the people knew that there were easier things for them to try and solve. They just didn't know how to go out and get them. But the easier thing to solve is, let's just look at the time it takes to do a changeover. And instead of you actually saying, yeah, okay, I've got a target of 45 minutes, actually, we're able to demonstrate that our mean changeover time in this case was just 42 minutes. We were already, on average, better than target. The problem is, look at the tail on that histogram. There were so many occurrences where it's double that changeover time that makes predicting production runs difficult. How can planning use that information with any kind of accuracy to say when the next job's going to be, or when the delivery of the next lot of raw materials, or when the wagon turns up in the yard, they're expecting to collect the goods or the production run that's just been completed. So again, one data point looking at time from last bottle to first bottle, and again, a little bit of theory around it, but using the data to drive that theory, where they drive down that target time from 45 minutes to 35 minutes and pinch in the sides of the histogram, make sure we get rid of that variability. So these are the kind of things that are real kind of tangible benefits that you can do really simply. You don't need to spend £1 million plus on infrastructure to get the data to make those kind of decisions that we're kind of showing you there in the talk. So I think that's enough kind of talking from me. Pass it kind of over to the audience. There's a couple of questions I can see that have come up on the terminal. So let's have a quick run through those.
Yeah, so just get them open. So there's one coming here from Peter, I think it is. It says, how do companies know where to start?
So it's a very good question. We'll have a lot of certainly companies come to us that are already in kind of solutions mode. I want a system that does this. Yeah. And at that point, the kind of alarm bells are going off in my head a little bit, because I don't know what the problem is they're trying to solve. They come to me in kind of solution mode. We need to kind of be able to step it back a little bit and go, right, well, yes, you said you need this, but why? What are you trying to do? And if we can get to those answers, it was, because we're trying to get 0.5% off the cost base next year, or then we can say, okay, now I might be pointing in a slightly different direction. Before, maybe the question was about production, but actually when you dig back into it, it's about quality. Yeah. So there's a part of it where we have to say, you, Mr. Manufacturer, you are the expert in your process, but we are the experts in capturing data and making the improvements. So we're going to need to kind of join those two things together, and try and push the manufacturing company out of solution mode, because they're best at making widgets. We're best at understanding how to get data to drive those improvements. So it's very it's a difficult conversation to have, because a lot of people do like to be everyone's an engineer. They like to kind of solve their own problems.
There was another one popped up, I think it's probably for me. I can't see it now, but it was when we were talking about cybersecurity. How do these solutions actually help in that? And I guess with it being IoT, you're still connecting devices to networks, that kind of thing. So I guess what we're experiencing, how we're dealing with that, is that it's by taking this kind of small data approach. There's two things really. You don't have to put everything on a network. There's things you can do with single point solutions that might go through a mobile network or through a Wi-Fi network. That actually they're secured as well. They're highly secure, but then you've got to ask yourself, what's on the end of that? There's a single sensor.
What can they see?
So you know, if you were really worried and you were going to the nth degree, it's kind of, well, actually, hang on a minute, if that was possible to get into, what actually are we going to expose?
Yeah, there's no route through to my network.
No, so you're getting to a photocell in the shop, on the shop floor, and that's going up and down.
Yeah.
And so obviously, you know, we still do these with security first approaches and that kind of thing, but it's kind of, you know, you could take your car keys every night, put them in a big box and chuck them in the river, but it's not going to get you in your car very quickly in the morning. Yeah. So that, you know, with cybersecurity, you've always got to think about the risks of actually what you're trying to protect. And with a photocell, you know, it's a smaller risk. So yeah, it's interesting. And then there's quite a few here, but there's one that I thought was interesting from Hannah. It says, do SimLogic work collaboratively with other providers?
Yeah, in an ideal world, I will say yes. There is only kind of one way to do innovation going forward, and that's by working collaboratively with. If you're a manufacturer, you have to work collaboratively with your supply chain. You know, without doubt, if you try and innovate without that, then you're essentially doing it in a bit of a tin box. You know, you've got to understand that. As I said earlier in the answer to the other question, you know, you are the expert in your process, and your supplier who makes cardboard boxes for you is the expert in making cardboard boxes.
Yeah.
Don't try and reinvent the wheel and reinvent your own cardboard boxes, because these guys are the experts. You have to work collaboratively to try and solve these problems.
Particularly when you're working with data and you're seeing patterns and so on, you need that subject matter expertise,
process knowledge.
To explain why you see certain things. So I can think of an example where we were seeing a trend of an output, exact same shape every day with a dip. And, you know, it wasn't at lunchtime, it wasn't at break time. We'd run out of, you know, our data analysis had run out of ideas. As soon as you put that in front of a subject matter expert, they said, I know what that is. That's what time the deliveries turn up. And, you know, and suddenly they could go and reorder some delivery stuff and actually make sure that gap didn't appear anymore. So you kind of have to work collaboratively, you know, first and foremost with the client and the end user, but then there's always going to be other people involved, OEMs and stuff like that, who know the equipment better than anyone. So
because everybody needs to kind of be open to working together, and that's not always. It's not always as straightforward as it might sound. It's maybe a little bit idealistic, or but you've got to try. You've got to try, I suppose. So at that point, I think we're going to have to wrap up today's session. The recording will be made available on our website and our YouTube channel. Again, if you do have any other questions or anything in the meantime, please feel free to send us an email to inquiries@simlogic.co.uk. Thank you very much for your time.
Thank you.